Okay guys, today we're going to work a little bit more on frowny face factoring, but we're going to make sure that we go through the factoring cheat sheet on each problem to ensure that there's not an easier way to do something. So on number 1, I have 3x squared minus 2x minus 5. Now if you remember, the first thing that you need to look for on your factoring cheat sheet is a greatest common factor. So if I look at 3, 2, and 5, 3, 2, and 5 are all prime, so there's no greatest common factor that goes into them. Then x squared, x, and no variable, so I can't take out a variable either. Then the next thing that we needed to look for was how many terms there are. There's either 2 terms or there's 3 terms. Now if there's 2 terms, that's when we wanted to look for a difference of squares. If there's 3 terms, we had to determine whether we had to use easy factoring or frowny face factoring as an option. And to figure out which one to use, we had to look at the a values. So if my a value is equal to 1, we could easy factor, and if my a value wasn't equal to 1, we had to frowny face factor. So on number 3, I have 3 terms, and my a value is 3, so that means I'm going to have to use frowny face factoring. So we're going to start by taking my a value of 3 times my c value of negative 5, and 3 times negative 5 gives me negative 15. Now I need to find the factors of negative 15 that add together to be negative 2. So I can list the factors of 15 of 1 and 15, 3 and 5, but since it's a negative 15, that means one of my factors has to be negative, and they need to add together to be a negative 2. Now if I end up with a negative number after I add them together, that means my bigger number has to be negative, and 3 and negative 5 are the two factors that add together to be negative 2. Next, I need to rewrite my expression. 3x squared is going to come down first, and I need to replace negative 2x with my two factors here. Now, when I replace it, it doesn't matter which one goes first, but we want the negative one to go first to make it easier on us. So 3x squared minus 5x plus 3x, and then we can bring down my minus 5. Now we group our two binomials, so 3x squared minus 5x and 3x minus 5. Notice there's an addition symbol in between my two binomials. That's what we want. Now we take out the greatest common factor on each binomial, so 3x squared minus 5x. The GCF can't be a coefficient, but I can take out an x here, and let's see what that leaves me with. 3x squared divided by x leaves me with 3x, and negative 5x divided by x leaves me with negative 5. Now for my second binomial, 3 and 5 don't have a GCF, and my first term has an x, but my second term doesn't, so I can't take out a variable. Now if you'll remember, that means we really need to factor out a 1, because when I factor out the 1, that helps me with what I have left, but it doesn't affect the binomial. Now let's see what I have left. 3x divided by 1 is 3x, and negative 5 divided by 1 is negative 5. Now at this point, you need to check your binomials. 3x minus 5 and 3x minus 5. They're the exact same, which is what we want, so that comes out first. Then my second binomial is whatever I have left. So I have an x in front of this guy and a plus 1 in front of that guy. So 3x minus 5 times x plus 1. Let's look at number 2. Again, the first thing I want to check for is the greatest common factor. So 2, 3, and negative 9. So 2 and 3 are prime, but 9 is not. Now 3 can go into 9, but 2 can't, so there's no greatest common factor there. M squared, M, and no variable, so I can't factor out a greatest common factor. Now we need to figure out how many terms we have. 1, 2, 3 terms, so this is out. And my a value is negative 1, so that means I need a frowny face factor. So take 2 times negative 9 to get negative 18. And I want the factors of negative 18 that add together to be 3. So again, you can list out your factors of 1 and 18, 2 and 9, 3 and 6, and if it's negative and we end up with a positive, my bigger numbers have to be positive, and the two that add together to give me negative, or positive 3 is negative 3 and positive 6. So now we can rewrite. So 2m squared goes first. Replace 3m with my two factors. I want the negative one first, so minus 3m, then my positive plus 6m, then bring down my minus 9. Then I can group my two binomials, 2m squared minus 3m and 6m minus 9. Don't forget, we need an addition symbol in between my two parentheses. Now we can take out the greatest common factor. 2 and 3 don't have a GCF, but I can take out an m. Now let's see what I have left. 2m squared divided by m leaves me with 2m, and negative 3 divided by m leaves me with negative 3. Now my second binomial, 6 and 9, both have a 3 in common, so I can take out a positive 3. And when I divide that out, 6m divided by 3 gives me 2m, and 9 divided by 3 gives me 3. Now if I stop and check, 2m minus 3 and 2m minus 3 are the exact same, so they can come out first. Now let's see what I have left. M starts it off, and plus 3 finishes my second binomial. So 2m minus 3 times the quantity of m plus 3. Let's look at number 3. Again, the first thing we need to look for is a greatest common factor. So 3, 8, and 4 do not have a greatest common factor, and 4 doesn't have a variable, so there's no GCF. I have 3 terms here, and my a value is 3, which means that I need a frowny face factor. So I'm going to take 3 times 4 to get 12, and I need to find the factors of 12 that add together to be a negative 8. Now the factors of 12 would be 1 and 12, 2 and 6, and 3 and 4. But since they have to add together to be a negative 8, I want the negative factors of 12. So that'd be negative 1 and negative 12, negative 2 and negative 6, negative 3 and negative 4. Now the ones that add together to be a negative 8 would be negative 2 and negative 6. Now when you write them down, guys, it's always a good idea to make sure you do like a mental check. So negative 2 times negative 6 gives me a positive 12, and negative 2 plus negative 6 gives me a negative 8. Now I rewrite my expression. The 3r squared comes down first, and I want the negative 1 to go first, but when they're both negative, we have to bring down the first one, so that's the wrong color. So we want minus 2r, and instead of saying minus 6r, that's when we want to put a plus a negative 6r, and then bring down my plus 4. And the reason we do that is so that when we group our binomials, we're still left with an addition symbol in between. Now we can take out the greatest common factor. So 3r squared minus 2r, 3 and 2 don't have a GCF, but again I can take out an r, and 3r squared divided by r leaves me with 3r, and 2r divided by r leaves me with negative 2. Now let's see what I have to take out of my second binomial. My first term here is negative, which means I have to factor out a negative number because we don't want that to happen. And 6 and 4 both have a 2 in common, so I can factor out a 2. Now let's see what I have left. Negative 6r divided by negative 2 leaves me with a positive 3r, and 4 divided by negative 2 will leave me with a negative 2. Now at this point, let's check our binomials. 3r minus 2 and 3r minus 2 are the same, so that can come out first. And then what I have left is r and minus 2. Let's look at number 4. The first thing I want to check for is the greatest common factor. So 9, 15, and 6. Whoa, 9, 15, and 6 all have a 3 in common, so I'm going to take out a GCF of 3. Now remember, when you take out a GCF, we always want to finish it with brackets, because if we do have to frowny face on the inside, we're going to be using a lot more parentheses, or easy factoring, we have to use a lot more parentheses, and it's just easier to see. So if we keep it with brackets, let's see what I'm left with on the inside. 9r squared divided by 3 leaves me with 3r squared. 15r divided by 3 leaves me with 5r. And 6 divided by 3 leaves me with 2. Then we can close our brackets. Now on the inside we need to keep going. So I took out the greatest common factor. Now let's see how many terms there are. 3r squared, 5r, and 2 gives me 3 terms. And I have an a value of 3, so I'm going to have to frowny face factor here. So we'll take our 3 times our 2 and get a 6. And I want to find the factors of 6 that add together to be 5. So two numbers that multiply together to be 6 and add to be 5 are 2 and 3. So now we need to rewrite our expression. But first, you need to bring down your greatest common factor and open up your brackets. That doesn't go away. Now when I rewrite it, the 3r squared goes first. The 2 and the 3 are going to replace the 5r. Now again, it doesn't matter which one you put first. So I'm going to put plus 2r plus 3r, and then bring down your plus 2, and you can close your brackets. Now we need to go through and we need to group our terms. So 3r squared plus 2r and 3r plus 2 with an addition sign in the middle. And notice, guys, when I put in my parentheses, it's a lot easier to see what's going on because I have these brackets. Now we just have to take out our GCF. So bring down your 3 and open your bracket. And let's see what I can take out of my first binomial here. 3r squared plus 2r. So 3 and 2 don't have a GCF, but they both have an r, so I can take one of those out. Now let's see what I have left. 3r squared divided by r gives me 3r. Then 2r divided by r gives me 2. Now my second binomial, 3r plus 2, 3 and 2 don't have anything in common. One term has an r, the other term doesn't, so I can only take out a greatest common factor of 1. And again, that's going to leave me with 3r plus 2. Then, close your brackets. Finally, let's double check our binomials to make sure they're the same. 3r plus 2 and 3r plus 2. They are the same, so they're going to come out first. So I have that 3r plus 2. And then whatever's left in front goes second. So r was in front of that first one, and plus 1 was in front of that second one. But don't forget, you need to bring down that greatest common factor to go in front. That's by itself all in the front. Okay, next we're going to skip down to number 7. On number 7, it says solve each equation by factoring. Here's where we start to solve, so we need to make sure that we have our answers in set brackets when we finish. So on 2x squared plus 20x plus 32 equals 0, the first thing that I look for is the greatest common factor. So 2x squared, 20x, and 32, those are all even numbers, so I'm going to take out a 2. And remember, when you take it out, put brackets to make sure everything behind it is easier to see. Now 2x squared divided by 2 gives me x squared. 20x divided by 2 gives me 10x. And 32 divided by 2 gives me 16. Then you can close your brackets and bring down your equal 0. Now on the inside, let's keep going. Let's see what else I can do. So I've taken out a GCF. Now according to our cheat sheet, the next thing that we need to look for is how many terms there are. And since we have 3 terms, I want to focus on the a value. This a value here is 1, which means I don't have to frowny face factor. I can easy factor. So bring down your 2, open your bracket, and then make your 2 binomials. Now, in our binomials, we need to have the variable that we're using first, and the second term is whatever multiplies together to be 16 and adds together to be 10. So if I find the factors of 16, I have 1 and 16, 2 and 8, 4 and 4. And the 2 numbers that add together to be 10 are 2 and 8. So that would be plus 2 and plus 8. Then we can close our bracket and bring down our equal sign. Now to solve, we have to take each one of our terms and set them equal to 0. Now at this point, the brackets really aren't necessary because we don't have any more factoring to do. So it's really just a 2 times the quantity of x plus 2 times the quantity of x plus 8 equals 0. Now I can take each one of these terms and set them equal to 0. So I can take my first term, which is 2, and set that equal to 0. I can take my second term, which is x plus 2, and set that equal to 0. And I can take my third term, which is x plus 8, and set that equal to 0. And we can solve. Now hopefully you'll notice that my first equation, 2 equals 0, isn't an equation at all, because we don't have a variable. And since this isn't true, it doesn't help us, and we can cross off that equal sign. Now x plus 2 equals 0, so I can subtract 2 from each side, and I'll get x equals negative 2. And x plus 8 equals 0, so I can subtract 8 from each side and get x equals negative 8. That means my two answers are negative 2 and negative 8. Let's try it again on number 8. First thing we need to do is check for a greatest common factor. Now, 3n squared minus 15n plus 18. There is a greatest common factor there. They all have a 3 in common. So I'm going to take out that 3 and start with my brackets. Now let's see what I have left on the inside. 3n squared divided by 3 leaves me with n squared. Negative 15n divided by 3 leaves me with negative 5n. And 18 divided by 3 leaves me with 6. Then I can close my brackets and bring down my equal 0. Now on the inside, let's keep it going. I have 3 terms going on here, and my a value is 1, so I can easy factor. So all I need to do is find the factors of 6 that add together to be negative 5. So the factors of 6 are 1 and 6, and 2 and 3. But since I want them to equal a negative number, that means I need the negative factors. And my two numbers are negative 2 and negative 3. So I'm going to bring down my 3 and open up my binomials. The variable goes first, so I have n, and the factors go second, minus 2 and minus 3. Then don't forget, you need to set it equal to 0. Now, I just take each one of my terms and set them equal to 0. So 3 equals 0, n minus 2 equals 0, and n minus 3 equals 0. Now I can go through and solve. Since there's no variable in my first equation, we can cross it out as it doesn't help me. My second equation, I can add 2 to each side and n equals 2. And my third equation, I can add 3 to each side and n equals 3. That means my final answers are 2 and 3. On number 9, I have 18a squared plus 10a equals negative 11a plus 4. So before we even get started here, it's very important that we start by setting everything equal to 0, getting everything over to the left side and getting equal 0 on the right. So to do that, I want to add 11a over here, and that's going to give me 18a squared plus 21a equals 4. Then I need to subtract 4 from each side. So when I subtract 4, I'm going to be left with 18a squared plus 21a minus 4 equals 0. Now I can go through and start to factor. So the first thing I want to look for is a greatest common factor between 18, 21, and 4. Now these three numbers kind of a little tricky for me, so I might go over on scratch paper and list the factors. So 18, I have 1 and 18, 2 and 9, 3 and 6. 21, I have 1 and 21, 3 and 7. And on 4, I have 1 and 4, and 2 and 2. Now, 18 and 21 have some good GCFs of 3, but 4 doesn't have that going on at all. So there's actually no greatest common factor between 18, 21, and 4. Now I need to look at how many terms we have. So 18a squared, 21a, and negative 4, that would be 3 terms. And my a value is 18, so I'm going to have to frowny face factor. So I'm going to start by multiplying 18 times negative 4. In my calculator, that gives me a result of negative 72. So the results of negative 72, I want to find the factors of negative 72 that add together to be 21. At this point, go ahead and pause the video and find those factors on your own. Here I've listed the factors of negative 72 that would be helpful for me. Since we end up with a positive result, that means my bigger number needs to be positive, and the two that add together to give me a positive 21 are negative 3 and 24. So I want to rewrite my equation, but instead of that 21, I want to replace it with negative 3 and 24. So I'm going to have 18a squared, bring down my minus 3a, and plus 24a. Then my minus 4 equals 0. Next we can group my binomials with an addition in the center and take out the GCF. So 18a squared minus 3a. 18 and 3 both have a greatest common factor of 3, and they each have an a involved, so I can take out an a. Now 18 divided by 3 is 6. A squared divided by a is a. And 3a divided by 3a leaves me with 1. Now my second binomial of 24a and 4, I can take out a 4, and 24a divided by 4 leaves me with 6a, and 4 divided by 4 leaves me with 1. Now my two binomials are the same, so I can bring out that 6a minus 1, and then I'm left with 3a and plus 4. Now finally, I can take each binomial and set it equal to 0 to solve. So I can take 6a minus 1 and set it equal to 0, and I can take 3a plus 4 and set it equal to 0. Now, 6a minus 1, I can add 1 to each side and divide each side by 6, and I'll get a equals 1 over 6. And 3a plus 4, I can subtract 4 from each side and divide each side by 3, and I get negative 4 over 3. That means my two answers are 1 over 6 and negative 4 over 3. Alright, let's go to number 10. On number 10, the first thing we need to do is we need to get everything over to my left side and set it equal to 0. So I want to subtract 6a over, so I'll get 8a squared minus 22a equals negative 12. Then I'll add 12 over to be left with 8a squared minus 22a plus 12 equals 0. Now that it's set equal to 0, let's look for a greatest common factor. So 8, 22, and 12. A 2 can go into all of those. So I'm going to start with a 2 and give me an open bracket. 8a squared divided by 2 leaves me with 4a squared. Negative 22a divided by 2 leaves me with negative 11a. And 12 divided by 2 leaves me with 6. Then I can close my brackets and set it equal to 0. Now on the inside, I want to look to see what I have left. I have 3 terms with an a value of 4, so that means I need a frowny face factor. So I want to find the factors of 24 that add together to be negative 11. Now, the factors of 24 that add together to be negative 11 are negative 3 and negative 8. So I can bring down my 2 and open my bracket and rewrite my 4a squared minus 11a plus 6 with my two new factors. So 4a squared, and again they're both negative, so it doesn't matter which one goes first, minus 3a plus negative 6a, negative 8a, goodness, plus negative 8a plus 6. Then I can close my bracket and set it equal to 0. Now I can go through and group my terms. So 4a squared minus 3a and negative 8a plus 6. And next we take out our greatest common factor. So I'll bring down my 2. 4a squared minus 3a both has an a in common. And 4a squared divided by a leaves me with 4a. 3a divided by a leaves me with a 3. My second binomial starts with a negative number, so that means we need to factor out a negative number. And then 8 and 6 both have a 2 in common. So 8a divided by 2, negative 8a divided by negative 2 leaves me with 4a. And 6 divided by negative 2 leaves me with 3. Then I can close my bracket and set it equal to 0. Now, finally, I want to see what I have left. So I'm going to bring down my 2 with my binomial. The 4a minus 3's are the same. So 4a minus 3, if my pen would work here. Geez, let me try that again. So I'm going to bring down my 2, and then the 4a minus 3 is in common. Then let's see what I have left. The a in front of that, and the minus 2 in front of that, and then set it equal to 0. So now what I'd like you to do is pause the video and set each term equal to 0 to get your final result. So when you set each term equal to 0, 2 doesn't have a variable, so that doesn't help us. 4a minus 3 gives me a result of positive 3 over 4, and a minus 2 gives me a result of positive 2. Alright, we're going to skip down to number 14 and then we'll be done. On number 14, first of all, it's set equal to 0, so we're good to go there. The first thing I want to look for is a greatest common factor. So 16 and 9 don't have a greatest common factor that I can take out. The next thing I need to check is how many terms does it have. So 16x squared minus 9 only has 2 terms, which means I want to see if it is a difference of squares. So a difference of squares has to have 2 terms that are both perfect squares, and it has to be separated by a subtraction sign. So 16x squared, 16 is a perfect square and x squared is a perfect square, so that works. And 9 is a perfect square, so here I have a difference of squares which is going to factor into conjugates. Now to get the first term of each of your conjugates, you need to take the square root of your first perfect square. So the square root of 16 is 4, and the square root of x squared is x. So that gives me a first term of 4x. Now to get the second term in your conjugates, you need to take the square root of your second perfect square number. So the square root of 9 is 3, and then we're going to have one positive and one negative. Then set it equal to 0. Now to solve, we take each term and set it equal to 0. So 4x plus 3 equals 0, and 4x minus 3 equals 0. Go ahead and pause the video and get me my 2 answers. So when you solve 4x plus 3 equals 0, you should get negative 3/4, and 4x minus 3 equals 0 should get you positive 3/4.